Myself MAMTA WANJRE, E&TC Department from AISSMS Institute of Information Technology. Today we see the topic linear regulated power supply design. The problem statement of linear regulated power supply design is design a dual polarity regulated power supply with following specifications: input specification 230 volt single phase 50 Hz, output specification output voltage equal to plus minus 5 volt, load current equal to 2 ampere, maximum ripple voltage equal to 5 millivolt, ambient temperature that is 25 degrees Celsius. From that we have to design linear regulated power supply. Let us see first the basic block diagram of linear regulated power supply. In that, input voltage to 230 volt AC is given to transformer, that is first block. Output of transformer is given to rectifier circuit. Rectified output is given to filter circuit, that is the next block, and output of filter circuit is given to regulator, that is a voltage regulator, and output of voltage regulator is given to load. While designing linear regulated power supply, first step is to draw the basic circuit diagram. Transformer, here we use step down transformer. So step down transformer output is given to rectifier circuit. There are different types of rectifiers are available: half wave rectifier, full wave rectifier. In full wave rectifier, basically we use bridge type of rectifier circuit. Output of rectifier is given to filter circuit. Normally we use capacitive type of filter circuit. Output of filter circuit is given to voltage regulator. Here we have to design dual power supply, but output voltage is given plus minus 5 volt, so that we select fixed voltage regulator. For plus supply we select 78 series, and for minus, for that we select 79 series. 5 volt output voltage is given, so 7805 and 7905 we select the voltage regulator, and output of voltage regulator is given to load. There are different types of voltage regulators are available: fixed type and variable type. Variable type of voltage regulator, its range is 1.52 or 252, 57, whatever depends upon that voltage regulator IC. LM317, LM350, these are the different variable voltage regulator or adjustable voltage regulator ICs are available. There are two capacitors are connected, input capacitor as well as output capacitor. Input capacitor is required if regulator is located an appreciable distance from power supply filter, and output capacitor that is connected to output side, it improves transient response. And adjustable capacitor that improves ripple rejection. And we have to calculate output voltage. For that, formula is also given in datasheet, that is 1.25 volt plus R2 divided by R1 plus I adjustable multiplied by R2 is there. There are fixed voltage regulator ICs are also available. For fixed positive voltage regulator IC we use 78 series. These are different 78 series are available, and for negative voltage supply we select 79 series are there. Let us see the different design steps. First step is selection of appropriate circuit topology. Second step is compute the maximum load condition. To calculate load, resistance or load, output voltage is given and load current is given. Output voltage here 5 volt is given and load 2 ampere is given. From that we have to calculate load resistance RL equal to output voltage divided by input output current, and that is the second step. Third step is select an appropriate 3-terminal regulator, that is voltage regulator I already told. Next step is compute the permissible minimum voltage at the input of regulator. That formula is ripple rejection, that is equal to 20 into log of maximum input ripple voltage divided by ripple voltage. Ripple rejection ratio that is given in datasheet of 78 series as well as 79 series. In our design problem statement, ripple voltage is given, and from that we have to find out maximum input ripple voltage for 7805 as well as 7905. Next step is selection of filter capacitor C1 and C2. That formula is C equal to load current divided by 2 into frequency multiplied by maximum input ripple voltage. Frequency, load current is given. These are given in problem statement. Maximum input ripple voltage we already calculated. Always consider minimum ripple voltage, and from that we have to calculate maximum capacitive type of filters value. Next step is selection of rectifier diode. There are different parameters, selection criteria of rectifier diodes are available. PIV rating and surge current. From that we have to select rectifier diode. Next step is selection of transformer. There are different types of transformers are available. Step down transformer, step up transformer. Step down transformer we require, and voltage drop across each components, and from that we have to find out the secondary voltage of transformer and convert that voltage into RMS value, and we get the secondary of transformer voltage, and from that we have to calculate number of turns ratio as well as current, and from that we have to select the transformer. Next step is selecting current booster circuit or current boost transistor. Current boost transistor is required whenever load current is greater than output current of voltage regulator. Next step is selecting transistors R1 and R2, that is considered whenever we consider current booster circuit. Last step, that is heatsink calculation. That is the very important calculation part. Heatsink, a necessary and primary requirement for the safe operation of any semiconductor device, whether it be an IC or transistor. The operating junction temperature, we calculated Tj equal to Ta plus power dissipation multiplied by theta Ja. That is the basic circuit diagram of that. Different steps of to compute heatsink requirement. First step is power dissipation Ta, Tj. These are given, and from that we have to calculate theta Ja. Calculated, that is equal to Tj minus Ta divided by power dissipation. If theta Ja calculated less than theta Ja device, then heatsink is required, because theta Ja is inversely proportional to power dissipation. When theta J is small, means it dissipates more power. When the device dissipates more power, means heatsink is must. So these are various steps to calculate the heatsink. it is required or not. That is the design of linear regulated power supply. Thank you.